class, I wanted to make a video working through a type of question that you might see in the homework sometimes, involving writing the equation of a piecewise function when given a set of data points. So suppose we're told that our data points make up what we call a line graph, and the data points that we are given are 3, 2, 4, 5, and 7, 1. So I begin, if I want to visualize what's going on, by understanding that if the inputs or my x values are 3, 4, and 7, and my outputs or my y values are 2, 5, and 1, that we are in quadrant 1, right? Both are positive values. So I could plot those points at 3, 2, 4, 5, and 7, 1. So 3, 2, roughly here. 4, 5, so 4 is 1, 2, 3, 4. 5 would be up here, something like that. And then at 7, 1, 7, 1, somewhere down here. Okay, and then I notice that I'm told that this is a line graph. So a line graph implies here that we connect our dots by line segments. So between 3, 2, and 4, 5, I'm going to do my best to draw a straight segment here. Not perfect. And so I notice between 3, 2, and 4, 5, that's what we're calling line 1, right? Line 1. And then I continue getting my second line segment between the points 4, 5, and 7, 1. So I'm going to try my best to draw a straight line segment here. Not perfect by any means. Apologize about that. Between 4, 5, and 7, 1, that's what I'm going to call line 2. Okay. And so to continue from here, the next thing I want to do is to come up with the equations of each of those linear pieces. Now keep in mind that for a normal piecewise function, you could have an assortment of pieces beyond just 2 pieces, right? There could be 3, 4, 5, there could be many, many pieces. But since we're only talking about line segments between these 3 points, so you'd get one line segment between the first 2 points and another line segment between the next 2, this only has 2 pieces in this case. It also is interesting to note that it turns out that at the point 4, 5, we should be, in fact, on both line segments, and that's because this is a line graph construction where we're simply playing connect the dots, okay? Whenever they tell you to make a line graph constructed with these points, that's what they're saying. Connect line graphs, by definition, typically connect the dots. And so this is what we call a continuous piecewise function, although in math, we oftentimes will see piecewise functions which are discontinuous, meaning we might have a segment of the graph here that stops at 4, 5, and then it picks up again at, let's say, 4, 7, somewhere up here, and then continues. So that could happen if we weren't talking about a line graph. But since it's a line graph, this is a continuous piecewise function. Okay, so what we want to do then is notice if they were giving us a template where they say g of x, our function's output, they could have said v of x for value. Whatever function name they choose to give is just your output, is determined by which segment of the line you're on, right? It's going to be different to get these values than it is to get those values. One has a positive slope and one has a negative. So in order to write the equation of a line, you could simply start off by using what we call the slope-intercept form. So to find the equation of this line segment, line 1, I would potentially use slope-intercept form y equals mx plus b. And I remember that in order to find the equation of a line in slope-intercept form, I need the slope and the y-intercept. The slope is easy to come by. If you remember, to get the slope between 2 points, 3, 2, and 4, 5, slope is equal to rise over run, or delta y over delta x. That's how we typically talk about change in science courses and math courses. Delta y over delta x is also known as y2 minus y1 and x2 minus x1. Also, rise over run, you can see visually, if I'm starting at 3, 2 and stopping at 4, 5, how much have I gone up and how much have I gone over? I've gone up from 2 to 5, that's 3 units, and I've gone over from 3 to 4, that's 1 unit. So you can probably see the slope is 3 over 1, but you could have also done it using the y2 minus y1. So y2 is 5 minus y1 is 2. There's my rise of 3 that we talked about. And then my run, if you will, x2 minus x1, 4 minus 3. That's my 1, my run of 1, which I saw here. So in other words, the slope here is 3 for line 1. Once you have the slope, you just need the y-intercept. And to get the y-intercept, we could simply use one or both of the 2 points that were given. So for example, if I use the point 3, 2 in the equation y equals mx plus b, my equation is currently at this location y equals 3x plus b. We're missing the y-intercept, right? Once we have the slope. To find the b, we can plug in an x and a y accordingly and find b. So this would mean if y is 2, we'd have 3 times x, which is 3 in this case, plus b. That means I have 3 times 3, which is 9. So 2 equals 9 plus b. Subtracting 9 on both sides, 2 minus 9 is negative 7. Let's see if this makes sense. So what we're saying is the equation for the first line is y equals 3x plus negative 7, or minus 7. This would be our line 1. Now that line 1 doesn't continue, right? Normally it would continue forever and ever, but it is forced to just be a segment because of this line graph stopping at 4, 5 and then continuing as a different line. So we need to make sure we tell the reader when this line occurs. So we can say, okay, yes, the line g of x, the output, is 3x minus 7, but only under certain conditions. Under which conditions? Well, between this x value and this x values of 3 and 4. And again, I can verify that this equation does in fact work. If I plugged in 4 into my equation, 4 times 3 is 12. 12 minus 7 is 5. So an input of 4 does produce an output of 5. So that is a point on that line. Okay, so I could have used either point to create that equation. Well, now that I have one of the equations generated for the first piece, the piece with the positive slope, let's see if we can do the same thing with the second piece between 4, 5 and 7, 1. So to begin with, I could do the same thing I did last time, and if you like using that method of y equals mx plus b, feel free to do so. But I want to show you another method. I'll come down here. That's called point-slope form. You remember what the formula was? Y minus y1 equals slope m parentheses x minus x1. And this point-slope form is very nice when you're given a slope and a point. So let's first find our slope between these points 4, 5, and 7, 1. Just like we did last time, change in y over change in x, or rise over run. You can see it's going to be a negative slope because it starts at 4, 5 and stops at 7, 1. How far down did I go? From 4 to 7? I'm sorry, I said 4 to 7. I meant from 5 to 1. I made that common mistake. From 5 to 1, how far down did I go? I went down 4 units, didn't I? And then how far to the right did I go? From 4 to 7? I went to the right 3 units. So my run was 3 to the right. My rise was down 4. In other words, negative 4 over 3. I could also have done this using y2 minus y1, right? y2 is 1 minus y1, which is 5, over x2 minus x1, 7 minus 4. And you, in fact, get negative 4 over positive 3. So the slope here is negative 4/3. Okay, now that I have the slope, I could go about it the same way we did last time by plugging in the slope and then solving for b using an x and a y. But I could just as easily do this formula here. Let's try it. So the formula says y minus y1. So you pick one of the points that are in question between 4, 5, and 7, 1. Let's say I pick 4, 5. If I pick 4, 5, let's say, then what does that mean? That means I'd have y minus my y value of 5, so y minus 5, equals my slope of negative 4/3, parentheses x minus my x value here for the point is 4. And then I could distribute here, and I'd get negative 4/3 times x, which is negative 4/3 x. I'd also get negative 4/3 times negative 4 over 1. That's a positive 16 when you multiply over 3. So positive 16 over 3 equals y minus 5. I know this looks a little funky, doesn't it? So I'm using the point 4, 5. Let me just make some space here. Tiny little board here, sorry. So what does that mean to us? Well, if I were to solve for y then, I could add 5 to both sides. I'd get y equals negative 4/3 x plus 16 over 3 plus 5. Now, working with fractions here, how do I add two fractions? They have to have the same denominator. So if I have 16 over 3 plus 5 over 1, I can multiply 5 over 1 by 3 over 3, and that's really 15 over 3. It also means 5. So if I want to combine then, I have 16 over 5 plus 15 over 5. I said over 5, I meant over 3, I apologize. I have 16 over 3, I can't read my own handwriting. 16 over 3 plus 15 over 3. 16 plus 15 in the numerator gives me 31, that's right. So this in fact is 31 over 3. We're using a lot of fractions here. You could have also used decimals. Okay, so now we have an equation of the second piece. So the second piece here for line 2 for this segment is a slope of negative 4/3, so negative 4/3 y equals negative 4/3 x plus 31 over 3. Now, when is that line allowed to exist? Only between the points 4, 5, and 7, 1. So we plugged in 4, 5 to get this equation, but what would have happened if I had plugged in 7, 1? Right? Well, if I had plugged in 7 here, I would get negative 4/3 times 7. Well, that would be 7 over 1, right? So 7 times 4 is 28, but it's a negative in front. I would have negative 28 over 3 plus 31 over 3, okay? And when I combine 31 minus 28, what do I get there? Do I get 3 over 3? Yeah, which is 1. And so, in fact, I do get the location of 1 when x is 7 in this equation. So this is between the x values of 4 and 7. We're allowed to include 7, and we say, well, let's exclude 4 here because I've already included it here. You don't need to include it in both places. Well, again, I hope this was helpful. I know that there were a lot of components to this question that hopefully was a little bit of a review for you of how to write equations of lines when given 2 points. You can either use the slope-intercept form, y equals mx plus b, or you can use the point-slope form, y minus y1 equals m times x minus x1, where you plug in the point x1, y1, and your slope after you use the slope equation. And at this point, I want to go ahead and leave it to you to go practice because math is not a spectator sport. Reach out to me if you have any questions. I'll see you next time.